everyone, welcome back to my YouTube channel. This is part 4 of our series 30 most important system design concepts. Before this, we have had 3 parts of this series in which we have discussed on 15 important system design concepts, and in this video we will be looking into next 5 important system design concepts. Topics which we will be discussing in this video are replication, sharding, vertical partitioning, caching and denormalization. So let's begin our video. Last topic which we discussed in the previous part of this series was about indexing. So what was indexing? Indexing was the quickest and most effective way to speed up the read queries on our database. But what if our user and our application grows? Then hence the database would also increase, right? Then what will happen? Eventually our database might fail. It might not be able to handle those many read requests. So that is why we have concept that is called as replication. So if you remember in our part 2, we had discussed upon on horizontal scaling. So what horizontal scaling meant was, if our traffic on our application increases, we had added multiple servers to optimize to handle the large number of requests. Similarly, with the database also, we will be having multiple databases so that it is able to handle the read queries whichever our database is getting. We can handle this by creating multiple copies of our database across multiple servers. So we will be having one primary database which is called as primary replica, or it is also called as principal database, and this database is going to handle all the write operation. And then we can have multiple read replicas that handle the read queries. So for write we will have primary replica, and for read we will be having our read replicas. Whenever data is written, they are written in the principal database, and it gets copied to the read replica also, so that they are in sync, and whenever user is trying to access any data, they get the updated value and not the stale value. And advantages of replication is it improves the read performance, since read requests are spread across multiple replica, reducing the load on 1 db. Previously we had to send all the read queries to 1 db, but here we have different dbs read replicas, so our traffic also splits between different databases. And this also improves the availability, since if primary or principal database this fails, then next read replica it can take over as the next primary replica. And replication is also great for scaling the read heavy application. This is about replica. But what do we do if we need to scale the write operation or store huge amount of data? This is about read replica. We have made multiple read replica database, but what about write operation? If there is multiple write operation happening now, and our application has grown and multiple users are trying to visit our website, then what do? A single database server, that is write replica, this will not be able to handle all the write queries which is coming, and it cannot handle those many requests efficiently. So that is why we have our next topic that is called as sharding. So what sharding is, instead of keeping everything, all the database in one place, we split the database into smaller and simpler manageable pieces and distribute them across the multiple servers. That is what is called as sharding, that our database is split into smaller and manageable pieces. This technique is called as sharding. And how it works is, we divide our database into smaller, this is our database, we are dividing it into smaller parts, that is called as shards. So here we have shard 1 and shard 2. Each shard contains subset of the total data. So here you can see, here we had a b c d. After applying hash function, and this is our shard key. So after applying hash function and all, you see that there are two subsets, that is shard 1, shard 2. Here a and c are stored in shard 1, and b and d, they are stored in shard 2. So we divide database into smaller parts, they are called as shards, and each shard contains the subset of the total data, and data is distributed based upon the sharding key, which we have seen that this is sharding key. By distributing data this way, we reduce the database load on each shard, and each shard is going to handle the portion of queries, and it is going to speed up the read and write performance since queries are distributed across multiple shards. So this shard is going to handle its own request for the data which is for the data which it is storing. It is like that. So every shard is independent, and it improves and increases the speed of read and write performance. um, Sharding, one more important thing which you should know is sharding is also called as horizontal scaling, or sorry, horizontal partitioning. It is also called as horizontal partitioning. Yeah, I have written it here that sharding is also called as horizontal partitioning so that you people remember it. So this is about sharding, but what if here, if you see, everything is split into row. Shard 1 is having AC and shard 2 is having BD. So the data is split by rows. But what if rows are not the real problem? Maybe for rows you can use this, but what if columns are also problem? Like for columns also you have 50 or some 500 columns there after this column 3, then what will you do? This also leads to the problem in our real world application. In such cases, we make use of vertical partitioning. So what vertical partitioning is? In vertical partitioning, we split the database by columns. It is not by rows. Now we are splitting our database by columns. Imagine we have some user table that provides information like profile details, login history, billing information. Everything is put in one table only. As this table grows, queries become slower. I mean, it becomes slower because table must scan many columns even when the request only needs few specific field. To optimize this, we make use of vertical partitioning, where we split the table into smaller and more focused table based upon the user patterns. This improves the query performance since each request only scans for the relevant columns instead of scanning the entire table. And it also increases the unnecessary disk input output operation, making the data retrieval quicker. But whatever we say, if we have to compare between memory and database, then database is slower when compared to memory. So that is where we get into our next concept, that is called as caching. Caching is used to optimize the performance of the system by storing frequently accessed data in the memory instead of repeatedly fetching it from the database. One of the most common caching strategy which we use is cache aside pattern. So how it works is, you can see in the diagram, when a user requests the data, the application first checks the cache. If the cache is present, then application retrieves it. But if cache doesn't have that data, it instantly returns it to the database, and database is going to give us back the data, and then cache is going to store it for the future usage, and it will return it to our application. That is what is called as cache aside approach for caching. Now the next time the same request is sent, then cache is going to get the data from its memory, and it is going to give it to the application, and the request will not go to database itself. Cache is going to handle it. And to avoid the stale data being sent, we have something called as live value or TTL. So after certain period of time, after some duration of time, the data in the cache also gets refreshed, or it gets deleted. Now let's get into our next topic, that is denormalization. Most of the relational database use normalization to store the data efficiently by breaking them into separate tables. While this reduces the redundancy, it also introduces the joins. When we have to retrieve the data from multiple tables, the data must combine them using join operations, which can slow down the queries as the dataset grows. So we have denormalization. This reduces the number of joins by combining the related data into the single table, even if it means having the duplicate data. For example, instead of storing the user and order in separate table, we can create one user order table, and we don't need any join operation here, and data is already stored together, and it would lead to faster queries and better read performance. Denormalization is often used in read heavy application where speed is more critical. So these are the important topics we have discussed in this video. Thanks for watching.